In the last video, we reviewed the primary trig ratios. Not only that, but we also talked about how you can find exact answers when you take sine, cos, or tan of an angle. Today, what I want to talk about is the secondary trig ratios. Secondary trig ratios. So you might have heard some of these terms before. You may not have, and that's okay. The first one is secant of theta. The next is cosecant of theta. And the last one is cotangent of theta. And based on the names, you might be able to guess which one is related to which of the primary trig ratios, right? Most easily, I think cotangent, you could probably guess, is related to tan, or the tangent, right? And cotangent is just the inverse. It's 1 over tan theta, or tangent theta. And because tan is actually equal to sine over cos, so 1 over sine over cos, you could instead write this as just cos theta over sine theta. So skip this middleman here, and you could say it's equal to this. So while tan is equal to sine over cos, cotangent is equal to cos over sine. So that's an important relationship to remember. Now cosecant is equal to 1 over sine theta. I remember this because cosecant, the S is the second sound you hear. It starts with C, so you might think it's related to cos, but it's actually related to sine. And the same is true for secant. Secant is related to cos. It's 1 over cos theta. So some people remember this because S and C, C and S, they don't go together the way you might think that they do. That's the way some people remember it. Up to you, as long as you remember these relationships. You want to remember that secant is equal to 1 over cos theta, cosecant equals 1 over sine theta, and that cotangent theta equals 1 over tan theta, and also it's equal to cos theta over sine theta, right? Remember that as well. Now, with this information, we can actually develop further relationships or definitions, right? Because we know cos of theta is adjacent over hypotenuse. So therefore, secant theta is the opposite. It's hypotenuse over adjacent, right? Same with cosecant. Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. So you can remember that. Same with cotangent, right? Tan is usually opposite over adjacent, so cotangent is adjacent over opposite. So you also have these definitions that you can use if you wish. All right, now let's move on. Let's talk about identities. And this is probably the first time you're hearing about identities in mathematics. Identities are just relationships between different things. For example, one of the most basic ones, and this is one we've already mentioned, is the quotient identity. Quotient identity. Okay, the quotient identity says that tan of theta equals sine theta over cos theta. That's the one I just mentioned previously, right? And cotangent theta is equal to cos theta over sine theta. Again, one I just mentioned. These are your quotient identities, okay? So not too bad, not too intimidating. But we also have some other things, right? We have the reciprocal identities. And these are also things that we just looked at, right? These are the ones that say cosecant theta equals 1 over sine theta. Okay, it says that secant theta is equal to 1 over cos theta, and it says that cotangent theta is equal to 1 over tan theta. And likewise, the opposite's also true. Sine theta equals 1 over cosecant theta. Cos theta equals 1 over secant theta. And tan theta equals 1 over cotangent theta. So you can rearrange these to get these instead. Okay? So those are the reciprocal identities. So we just covered all these, but they have their own names. Okay? Quotient identities, reciprocal identities. It's not the most important that you remember what they're called. What's important, though, is that you're able to recognize these relationships. Okay? Now, there's other identities as well. Actually, there's an endless list of identities, seemingly endless list. The next one we're going to talk about is one that's going to be really useful, and it's called the Pythagorean identity. Pythagorean identity. Now, Pythagorean, you probably recognize that from the Pythagorean theorem, right? Which says that when you have a right angle triangle, you have A, B, and C, and we say A squared plus B squared equals C squared. And if you're thinking of that, that's perfect because that's exactly what the Pythagorean identity is, just with a little bit of tweaking, right? For example, if this is angle theta, and we say that C is equal to 1, how could I define side A? Well, I know that cos of theta is equal to the adjacent over hypotenuse, so A over 1, or just A, right? So A is equal to cos theta in this case. And I could say that sine theta is equal to B over 1, right? Opposite over 1, or just B, right? Because B over 1 is just B. So B is equal to sine theta. So now that I know A is equal to cos theta and B is equal to sine theta, I could plug those into your Pythagorean identity, right? Or your Pythagorean theorem, I should say. I could say that cos theta squared plus sine theta squared is equal to 1 squared, because we said C was 1, right? So I'm just plugging these definitions into your Pythagorean theorem to get this. And now we can simplify this a little bit. Typically, we don't like to put these brackets around cos theta. It just looks kind of messy. But we also don't want that 2 to be right next to the angle theta, because then it's unclear if we're squaring the whole thing or just the angle. So what common practice says is to just write it like this, cos squared theta. That implies you're squaring the whole thing like this. So get used to seeing that. Same is true for sine, and then 1 squared is 1. This is your Pythagorean identity. So if you take the cos of an angle and square it, and add it to the sine of that angle squared, you're going to get 1 when you add those numbers together. This is your Pythagorean identity. Don't forget about this. It's probably one of the most common ones that you're going to run across. Okay? Now there's different variations on this, right? Like you could divide all 3 of these terms by cos squared theta, for example. If you did that, you would get cos squared over cos squared plus sine squared over cos squared equals 1 over cos squared. And this would simplify to cos squared divided by cos squared is 1. Sine squared divided by cos squared is tan squared theta. And 1 divided by cos squared theta would be secant squared theta. So this is just one variation on the Pythagorean identity, right? You could do the same thing with sine, right? You could divide all of these by sine squared. If you divide them all by sine squared, you would get cotangent squared theta plus 1 equals cosecant squared theta, right? I didn't show the work for this one, but if you want to do it on your own, you can do that same process and see if you get the same thing that I got, okay? So these are variations on the Pythagorean identity, but most importantly, remember this primary one up here, the main one. Cos squared plus sine squared equals 1. That's the one I want you to remember. Now, with all this being said, right, all these identities are just tools that you have to conduct proofs, right? So let's work on some proofs. Proofs, if you're interested in mathematics, is a lot of what you end up doing in post-secondary studies in math. For this example, I'm going to be told that we have 1 minus sine theta divided by 1 plus sine theta, okay? And I'm told that's equal to secant theta minus tan theta. That's all in brackets and it's being squared. And I'm asked to prove this identity. That's the question. Well, hang on, we've never done proofs before. What does that mean? Well, all it means is that we have to manipulate either side or both sides of this identity and try to make both sides look the same, right? At the end of the day, I want both the sides to look the same and then I'll be happy, then I'll be done. So let's choose the right side at first to work on. Okay, so I'm going to say right side equals, and I'm going to write this out, but I'm going to simplify things a little bit. I don't like that this is written as secant and tan. I kind of like everything to be written as sine and cos. That would be my first tip for you, is try to write everything in terms of sine and cos. Secant theta is equal to 1 over cos theta, right? And tan theta is equal to sine theta divided by cos theta. And that's being squared. So that's the first thing I'll do. Change these terms into coses and sines. Because now I'm speaking the same language, right? I'm using sines and coses. I can start putting things together, right? This is going to equal 1 minus sine theta over cos theta because they have a common denominator, right? And that's being squared. And from there, I can actually simplify it a little bit more. I can say 1 minus sine theta squared is what I have on top, and on the bottom, I just have cos squared theta. So that's what I have on the right side. Now, let's move over to the left side, because it looks like I kind of did everything I could here. Let's go to the left side and see if I can change the left side to look like this. Right, that's my goal. Well, on the left side I have 1 minus sine theta divided by 1 plus sine theta. Now, if you look, the top is 1 minus sine theta. Over here, the top is 1 minus sine theta squared. So they're already pretty close to being the same. All I have to do is multiply this top by 1 minus sine theta, and my numerators will be the same, right? But whatever you do to the top, you also have to do the bottom, so I'm going to do that. Okay, so next step, I can simplify the top, say it's 1 minus sine theta squared, same as this. And on the bottom, I'll have a binomial times a binomial. I can FOIL that, right? 1 times 1 is 1. 1 times negative sine theta is negative sine theta. Sine theta times 1 is plus sine theta. Sine theta times negative sine theta is minus sine squared theta. Okay, so I'm getting close, right? The tops are the same. Let's simplify the bottom now. So I'll have 1 minus sine theta squared on top. And on the bottom, negative sine theta and positive sine theta will cancel, and I'm left with 1 minus sine squared theta. So I'm really close, right? I just have to show that this and this are the same, right? Or I have to change this to look like this. How can I do that? This is why I said to remember your Pythagorean identity, because the Pythagorean identity says that cos squared theta plus sine squared theta equals 1. If you move sine squared theta to the other side, you see that cos squared theta is equal to 1 minus sine squared theta. So you can swap this out for cos squared theta because they're equal, right? And so on the left-hand side here, I'm just going to change that denominator. So I'll have 1 minus sine theta squared divided by cos squared theta. That's now the same as this. I can say my left side is equal to my right side. Therefore, I am happy. My proof is complete. Okay? That is the essence of how you complete a proof in trigonometry. That's just one example. We're going to do lots and lots more examples in the next video, so stay tuned for that.